Fundamentally, the entire modern semiconductor pipeline relies on three core pillars: chip design, chip fabrication, and chip testing. For decades, moving a new chip from the initial digital design into physical fabrication was a seamless handoff. That handoff relied on process design kits, or PDKs. These kits provide the exact blueprint rules that ensure a digital design will actually work when it is manufactured on physical silicon. These mature PDK rulebooks are the foundation that made predictable, scalable electronics possible for the last several decades. But as Moore's law hits its physical limits, the industry is forced to find new ways to build hardware. To keep pushing performance forward, the industry is shifting towards advanced integration methods like 3D packaging and silicon photonics. Because these technologies are so new, they completely lack established PDKs. The industry standard rulebooks we depended on simply do not exist for this next generation of chips. Without this standard protocol, the once seamless bridge between design and manufacturing collapses. Hardware engineers are suddenly thrown back into an era of manual simulation. To optimize a single next-generation design, teams are forced into a labor-intensive cycle of manual simulation, tedious physical design, and trial-and-error optimization. Without a standard blueprint, hardware innovation is gridlocked by an unsustainable manual human bottleneck. InPhAI is a custom software solution engineered to eliminate this manual simulation bottleneck. Instead of slow, sequential human trial and error, InPhAI orchestrates multiple simulation platforms simultaneously. The AI drives these platforms to run concurrent tests, instantly processing the variables required for next-gen chips. InPhAI repairs the broken pipeline by replacing the missing static rulebook with a dynamic, real-time artificial intelligence layer. The software unifies the fragmented ecosystem of simulation, optimization, and design into a single automated environment. This shifts the effort from manual human repetition to concurrent software automation. The AI communicates directly with different, separate software platforms at the same time. This concurrent communication eliminates the massive wait times previously inherent in advanced chip design. The system iterates through permutations in a fraction of the time required by manual simulation, arriving at an optimal design ready for fabrication. InPhAI automates the exact workflow step that was suffocating next-generation hardware development. InPhAI reinvents the chip design stage for the post-Moore's law era. By bridging the gap to fabrication, the hardware potential of 3D packaging and silicon photonics moves from the lab to the factory. This chart shows a critical divide. The flat line is the stagnant supply of specialized engineers, while the rising curve is the complexity of next-gen design. By replacing manual hours with automated simulation, the software lets projects advance despite this global talent shortage. Lowering these R&D and labor costs empowers SMEs and startups to enter the advanced chip market. By removing the prohibitive cost of manual labor, InPhAI allows more companies to participate in advanced hardware design, reopening the pipeline and accelerating the entire industry's time to market.